Assalamu alaikum, brother Aziz. Today in this course we are going to learn about algorithms. Okay, so these videos that I am creating is very necessary videos for the quiz. So I gone through all the slides, right? And I already written a lot of notes on these algorithms. But here in this video I will going to explain you things in a very simple way, as it is requested in our quiz, and we will try to keep it as simple as possible, but we will try to learn as much as possible in the given time constraint. Okay, great. So what is an algorithm? So algorithm can be understood as the set of steps, in order to do something. In a general way I'm speaking. In a programming language, an algorithm can be defined as a set of steps to reach from one place to another. For example, let's say you want to reach from your home to the mosque. Okay, you want to reach to mosque from your home, so you have to do like wudu, and then you will wear your clothes, right? And then you will go to the mosque. Like, there are some set of steps, the step number 1 and step number 2 and step number 3 and so on, step number n. So all these steps that you create in order to solve something, that is known as algorithm. So in this very introduction course, we will going to learn about how we can analyze the algorithm. For example, let's keep a scenario. So there is a problem. Let's say the problem is P. Okay, the problem is P. In order to solve this problem P, we are having 4 algorithms. We are not having one algorithms, we are having 4 algorithms. Let's name them A1, A2, A3 and A4. So now the question arises that we having this problem P, okay, and we are having 4 algorithms to solve this problem. Okay, let me correct these arrows. Actually, A1 to solve this problem P. So why we use any one among them? Why we are not using any of them? For example, so this is correct for this, this is correct for this, this is correct for this, this is correct for this. So why we are comparing? We are comparing because we will going to use the algorithm that is most efficient. And what is the meaning of most efficient? Well, any algorithm which is most efficient will going to having 2 things that we have to follow. The one is space, and another one is time. We need algorithm that will take minimum space and minimum time. It should not taking a lot of memory, right? It should not taking a lot of memory, and it also not should take a lot of time. If it is taking a lot of time and a lot of memory, we will not consider that algorithm. So we will analyze all the algorithms, and with respect to our analysis, wherever we find out that the time and the space is less, so we will going to take that algorithm for our program. Okay, now how we will analyze this? That is the thing that we have to learn. Well, earlier what happened was, whenever there was no such methods, no mathematical tools like asymptotic notation, so what people used to do was they used to analyze the algorithms on computers. For example, let's say this is one computer, this is another computer, and this is another computer. So what they thought is, if I will run an algorithm A1 here, and same A1 here, and same A1 here, and then I will run A2 and A2 on these computers, so it would be kind of the one who will give the best results. That algorithm will be kind of the best algorithm. That is what people used to do earlier, when there is like no asymptotic notation. I will explain you what is asymptotic notation is, but just we want to prove this one is wrong. This is known as iterative type of analysis. So this is wrong because let's say A1 is working very well on this computer, very well on this computer, and A2 is not working good in this computer. But what if A1 is compatible with these computers only, but A2 is compatible with every computer in the world, every computer in the world except this computer. Again, I am saying that what if A1 is compatible very good with these three computers, where A2 is not very good compatible with these three computers, but A2 is very well compatible with every computer present in the world except these three, where A1 is just compatible with these three computers but not any computer in all the world. So what would be happen then? Well, so this is type of analysis is, we cannot permit, because if this could be happen, then we are unable to find the efficiency of any algorithm. So now the question arises that then how we will gonna find it? Well, the answer is simple. We will going to find it with the help of asymptotic notations. Now what is asymptotic notation? These are the mathematical tools, and they are used to find out the cases, I mean the worst, the best and the average case of any algorithms, right? So these are asymptotic notations. Okay, they are classified into three categories. I will tell you what are they, and we will also going to work on them. I mean, I will going to explain you that. The first is big O, right? And the second is big omega, and the third is the big theta. So what big O is used for, what big omega is used for, and big theta is used for? Well, big omega is used for finding the worst time complexity of any algorithm, where big omega is used for timing the best time complexity of any algorithm, and this theta is used for finding the average time complexity of any algorithm, right? So why we find the worst time or average time, or let's say this best time? The reason is to know the efficiency of any algorithm, that what algorithm is doing on what way. But I want to add one thing Aziz here, that we are not going to find this two case first. Always we will going to find this case first. The reason is because if an algorithm is working well on the worst scenario, then it is automatically, we know that it will work well for the best and the average time. So we will going to find the scenario that is the worst case, and with respect to that scenario we will be going to tell that whether the algorithm is best or not, right? So going with the definition of the slide, in a definition it is saying that an algorithm is a sequence of unambiguous instructions for solving a problem. I told you that same thing they have written in the slide also, that is for obtaining a required output for any legitimate input in a finite amount of time. Can be represented in a various forms. An algorithm is a sequence from start to end, and it should be a clearness, unambiguity, effectiveness, and finiteness, and termination. All these points are there, that how our algorithm should be, and obviously it should be correct, so the correctness. So these few things that we have to follow while designing any algorithm. So now I will going to give you a practical analysis that is not present in the slide. I have my own notes, so from my own notes I will going to give you the practical analysis of any algorithm, that how we will going to analyze any algorithm. So I am just pausing the video to write the table here. Okay, so I have these numbers, these 1 2 3 4 5 numbers. So now I will going to place these numbers in an array, and then we will analyze about what is the best condition, what is the worst condition, and what is the average condition that we will get any element. For example, let's say we have this array in this form, that is 5 4 3 2 and 1, right? And now we have to sort this array. Okay, so when we will sort this array and put into the order, that is the ascending order, so we will like 1 2 3 4 5, right? But it's not that simple for a computer. So computer will have to visit each and every node, right? It will going to visit 5 times, 1 2 3 4 5 6, and it will going to compare, and then it will going to interchange. It will visit, compare, interchange. visit, compare, and interchange. When it will perform all kind of operation for the n elements, so that kind of complexity, that is order of n, is known as the worst time complexity. Why worst? Because it will be going to happen in each and every element. We are unable to sort, we are unable to perform any operation, that is, we cannot skip any of the element. We have to go to each and every element, and then we are performing the operation. So that will take a lot of time. It will take order of n time. So that kind of the condition comes under this case, which is worst case. Now we will going to find the best case. So what is the best case? Well, let's say I have an array. This is that array, 2, 3, 4 and 5. Okay, now I have to find any element. I have to find x, and the value of x is 2, right? So the 2 I got here only in the very first position. So its time complexity is order of 1. Why order of 1? Because I found it here only. So because of that reason, I declare that, okay, so the best time complexity of this is order of 1. So this is how n time complexity of order of 1 takes into the picture. Now the average time complexity is that when we will going to have an average. For example, this is an array, okay, and you see this array is containing numbers, okay, and these numbers are basically sorted numbers such that if we can implement binary search here. So what is binary search? Let me tell you. So binary search is a search that will going to have a pivot element in the middle. Let's say pivot is 3 here, and all the element left hand side of the pivot is smaller, and all the element right side of the pivot are the larger. Okay, so when, let's say I have to find x, and the value of x is, let's say, 5. Okay, so I will directly go here and I will go and search 5 here. I don't want to search for this list. I don't want to find this list, right? So this kind of the order will we get is, we have just subtracted the list from the half side. We are not traversing whole list. We are not traversing n number of elements, but we just traverse this much of elements. So the order will be order of log n, and this can be understood like here we can find any element with respect to its average keys. Okay, now we are moving to the next topic. So we discussed what is algorithms are, why they are used for, how we will going to find out what algorithm is the best, right? Now we're gonna look about what is a program, right? So we have discussed about an algorithm. Now we can just discuss about what is a program. So program can be defined as expression of an algorithm in a programming language. So there are various programming languages like C, we are having C++, we are having Java and whatnot. So these set of steps that we wrote in our English language, if we can convert into a working code that will going to really solve a problem into a compiler, so that set of instructions in a program is that set of instructions in any language is known as a program. So and algorithms can also be defined into the two types. The one is known as not actually two types, there are various types we can define. It is not actually written in this slides, but there are various ways, like we are having iterative way, we are having a recursive way, but what mentioned in slide, let's be bound towards that only for now. So one is probabilistic algorithm. So it's, I hope I'm pronouncing it correctly, it's probabilistic algorithm. I will tell you what it is. And the second one is heuristic algorithm. So first, what is probabilistic algorithm? So probabilistic algorithm is an algorithm where we're gonna choose the values in such a way that we have known the probability of those values. For example, I just want to give you an example here. Let's say I have having a bag. bag. Okay, I have some items in the bag, 2, 4, 2, 5, 7 and 10. So these are the number of items in each bag, and if I will sell these items, so I will get profit of, let's say 1.5, let's say 10, let's say 3, and let's say 15.